Good evening, ladies and gentlemen. Mr. Martineau here, Miss Mandarelli behind the camera, bringing you again another quarantine edition of Waves, Unit 6. Yesterday we talked about speed of a wave, VF and lambda. We started talking about frequency, but today we're going to do a little bit more into frequency and give it a little more detail. So we want to talk about frequency in another unit called period. So let's come on over to the board. So today we're going to look at frequency. Look, I got not a spoon anymore. We have frequency.
Oh, you have a ruler this
yes,
time.
it's recycled.
Oh.
Frequency versus period. And so the question becomes, what's the difference? And there is a difference. So let's take a look at a wave again. So once again, I have drawn a wave. It's different. Don't panic.
But it looks different.
Yeah, don't panic. This wave starts not at zero, but a little bit above. It goes this way, gets as far away from where it started as possible, and then it comes right back. So it starts at this point, goes as far away as possible from where it started, but then eventually goes back to the same spot that it started at. So I would call this, if you've ever seen a pendulum clock, and I get over here. So if I have a pendulum clock, it starts down here. You pull it back. So this is its starting point, right? It goes through. It gets as far away from the starting point as possible. And then what does it do? It ends up back at the starting point. So it goes far away, back to the starting point. Far away, back to the starting point, right? Let's look at our graph again. Starts here, gets as far away as possible, ends up back where it started. So this is one wave. Okay, so no, it didn't start here, but that's okay. We're going to say that it starts here. Starts, finishes. The key part here is that it finishes in the same location that it starts, just like a pendulum clock. So let's come down here. The wave begins at start and it ends at finish. When the wave returns to its original position, we say it has gone through one cycle of that wave. So this wave represents one cycle of the wave. If it did it again, it went this and it came over here, that would be 2 cycles of the wave. If I kept going, that'd be 3 cycles of the wave. And so I don't have enough paper for that. If I had my board, that'd be another matter, right? So this is just going to be one cycle of this wave, right? Start to finish. So let's review from yesterday. Frequency is, instead of waves, we're going to say cycles. So frequency is the number of cycles per 1 second. And as a review, the symbol for frequency was F, and the units was hertz, or Hz. So we should remember that from yesterday. It's the number of cycles per second. Now we're going to introduce a new idea, and that's called period. So before we go into period, okay, period, what do you know that has a period that is periodic, right? Well, when we were in school, you had period 1, period 2, period 3. Period 4. They all had a specific amount of time, all right? What is the period of the lunar cycle? You might not know, but the period of a lunar cycle is 28 days. Like, how long does it take, right? This period that we're going through now in history, the COVID period, right? Who knows how long it's going to last? Hopefully not long, hopefully shorter than later, but still it is a period. In the Civil War period, it's 4 years in the 1860s. So it represents an amount of time. So let's go back to our example here. A period for a wave is the number of seconds, so there's time, per 1 cycle of our wave. So we're going to time how long it takes 1 cycle to happen or 1 wave to go by. The symbol that we're going to use for period, well, since it's time, we're going to use capital T. It's just like T before. It's just going to be time, and the units for time are always seconds. Doesn't matter that we're talking about a wave. Time is time, and the time is a way to measure how long something takes to happen. So let's go. Frequency, number of cycles per 1 second. Period, number of seconds per 1 cycle. That should sound familiar. Number of cycles per 1 second, number of seconds per 1 cycle. It sounds like they're opposites of each other, and they kind of are. So how are period and frequency related to each other? Here's the formula. Frequency is equal to 1, the number 1, divided by the period t. And the period is equal to 1 divided by the frequency. Look, it doesn't matter if you know this, but I'm going to say it. They're inverses of each other. They're not opposites. That would be a negative number. They're inverses. They're flipped upside down. Look, the T flipped upside down is the F, and the F flipped upside down is the T. Either way, that doesn't matter. If you're not digging that, this is how you calculate it. Frequency is 1 over the period, and period is 1 over the frequency. Let's do an example. A wave has a frequency of 45 hertz. What is its period? So we're asking for period. Period is T. That equals 1 over F, 1 over 45. I'm not a genius. I put this in my calculator. And I got 0.022 seconds. There's a point in there. 22 seconds. Time, seconds. What does this mean? This means that one wave happens in 0.022 seconds. So basically what we're saying is that I timed this wave that has a frequency of 45 hertz. I saw that one wave went by, I timed how long it took, and it took 0.022 seconds. So that must be a very fast wave because one wave went by in 22 thousandths of a second. So that must be a pretty quick wave. One way to look at it. Okay, down to here. Example. A wave has a period of 3.6 seconds. What is its frequency? So here's frequency equals 1 over the period. So that's period is 3.6 seconds. Seconds is period. 1 over 3.6 equals, put that in my calculator, 0.278 hertz. Frequency is hertz. What does that mean? What's that number mean? This means that 0.278 waves happened in 1 second. What? What does that mean? That means not even an entire wave went by after watching it for 1 second. In fact, about a quarter of the wave-ish. Because 0.25 is a quarter, right? So 0.278 waves happened. So not even a whole wave happened in 1 second. That's probably a pretty slow wave. 1 Mississippi, and you're only a quarter of the way done. So that's a slowish wave, and that might be a fast wave. We'd have to do more analysis, but that's probably something we could conclude, and there's some evidence for which would support our conclusion. You know, that whole
Evidence
and numbers thing.
Science evidence.
So, lecture 2 on waves is done. Now you should have everything that you need to do worksheet 19.1, which is the lesson on May 19th. Not a lot of math. It's just basically if you can do 1 divided by a number. But the thing we're going to be looking for is, do you know the difference between the units for second, units for period, and units for frequency? And will you be able to tell us what they mean? I don't care that you can do 1 divided by 45 and get this number. You need to know that it means seconds, and you need to know what it means here. I don't care if you can put 1 over 3.6 in your calculator and get that number. You need to know that that's frequency, it's hertz, and what it means. Because numbers without labels are just numbers. Mm-hmm. And that's math class. And there's nothing wrong with math class, but we're not math class. Okay? So, quarantine edition. Mr. Marno here. Miss Mange on the phone.
Yep.
We will see you next time. Thank you very much, and stay well.